And once again, we are going to graph each of these, because if you graph them, you go through all of the steps, all of the things, and you can figure out any question. Like this one's asking about horizontal asymptotes. That's part of the graphing. So for part A, we always start off by factoring. The top factors to x plus 7, x minus 1, and the bottom is x plus 2. Once it's factored, you can list your non-permissible value. In this case, x can't equal negative 2 because it would cause you to divide by 0. And then you have to make a decision, is that non-permissible value going to be a whole, or is it going to be a vertical asymptote? If the non-permissible value simplifies and goes away, then it's a whole. If it doesn't simplify and go away, it is a vertical asymptote. So we have vertical asymptote at x equals 2. Next, we have to decide if there is going to be an oblique asymptote or a horizontal asymptote. And there was 3 situations. Either the degree is bigger on the top, the degrees are the same, or the degree is bigger on the bottom. Those are your 3 situations. In this one, we have the degree is larger in the numerator. So if it's larger in the numerator and things didn't simplify, this is the situation where you have an oblique asymptote. And you find your oblique asymptote by dividing, using synthetic division. So our original function was 1x squared plus 6x minus 7. We're dividing by x plus 2, so you put a minus 2 out in front. Bring down the 1, multiply, and add, multiply, and add. Okay? And your oblique asymptote will be at y equals x plus 4, and you can ignore the remainder. Now, someone in the other class was like, why does that work? Why does it become an oblique asymptote? Well, if we write the division statement could look like this. The division statement is x squared plus 6x minus 7 equals x plus 2, x plus 4 minus 15. This is our polynomial divisor. You don't have to write this down. But if you like an explanation of why there is an oblique asymptote, this is going to provide that explanation. Okay? What are we graphing? We are graphing x squared plus 6x minus 7 divided by x plus 2. So if I divided each of these by x plus 2, this by x plus 2, and this by x plus 2, I would get x plus 4 all by itself minus 15 divided by x plus 2. And your horizontal and oblique asymptotes tell you what happens when x gets really, really big. Okay? What happens as x gets really, really big in this one? You're left with x plus 4, and that will be 0 if x is really big. Does that make sense that if you put a very big number into there, that will be 0? And you're left with just y equals x plus 4. So when things get very, very big, this is the explanation. You don't need to know that explanation, but someone in the other class said, I want to know why we have an oblique asymptote. Why does it make sense? There's the explanation. If you're not worried about why, you just need to do the synthetic division, and you'll find your oblique asymptote. We still find our x-intercepts and y-intercepts. Y-intercept is really easy. You plug in 0 for x. Look at your original equation. You're going to get negative 7 over 2. And you'll also get very quick at finding your x-intercepts. Your x-intercepts, plugging in 0 for y, If you use the factored form, if you plug in 0 for y, the only place a fraction's equal to 0 is if the numerator is equal to 0. It's already factored, so you can have 1 at -7 and 1 at +1. Once you've found all of your asymptotes, your x-intercepts and y-intercepts, you're pretty close to being ready to graph. You might even be completely ready to graph. You might have to find some other nice points. So we're going to look at what does it look like. Well, we have a vertical asymptote at, oops, I made a mistake here. See this here? If the non-permissible value is -2, then your vertical asymptote should be at -2. The vertical asymptote is at x equals -2. Our oblique asymptote is y equals x plus 4. So I used my y-intercept and my slope to graph that line. I label the points that I know. I know that I'm going to have 1, 4, 5, 6, 7. -7, 0. 1, 0. And 0, -7/2. So for nice points, you need 1 point per section, minimum. Sometimes you need more, but at least 1 point per section. And your sections are always split up by your vertical asymptote. So if you look at x equals -2, you will notice you have points to the right of it. And this will be enough information to graph it going towards the asymptotes. In this section, we have a point. This is enough information for it to go towards the asymptotes. We don't need any more nice points to finish graphing this. So what makes this unit unique or sometimes difficult is the steps stay the same, but the graphs look a lot different every single time. But following the steps will create the technique for drawing the graph no matter what. So let's look at part B. Now just write our steps again. Graph B was the same equation. It'll factor exactly the same. But this time the x plus 2 is on the top, and the x plus 7, x minus 1 is on the bottom. So we factored it completely. Our non-permissible values are different. Now x can't equal -7, and x can't equal 1. Neither of those are wholes because nothing cancels out. So they'll both be vertical asymptotes. And now we have the situation where the degree is larger in the denominator. So what kind of asymptote does that make? A horizontal asymptote. And this is the easiest horizontal asymptote. If it's bigger at the bottom, when you put in a large value of x, the bottom will get much bigger than the top, right? If I put in a big number like 1,000,000 in for x, on the top, I'll have 1,000,000. But on the bottom, I'll have 1,000,000 squared, because the bottom has a square. So the degree is bigger on the bottom. That means that number on the bottom will get bigger much faster, giving you a horizontal asymptote at y equals 0. Find your y-intercept. Again, really easy. Plug in 0 for x. Get 2 over -7. Find your x-intercept. Again, really easy. Plug in 0 for y. The only time a fraction is equal to 0 is where the numerator is equal to 0. And so you get -2. X equals -7. X equals 1. Those are vertical asymptotes. Y equals 0. Horizontal asymptote label. Label your y-intercept. Label your x-intercept. And this one we're going to need some nice points. First of all, you might feel like you did something wrong because you have a horizontal asymptote at y equals 0, and you have a point on your asymptote. Okay? It's normal to feel like that's wrong because you're used to vertical asymptotes. Vertical asymptotes are for non-permissible values, and your graph can never, ever go through a vertical asymptote. However, horizontal asymptotes just tell you about end behavior. Sometimes a graph goes through a horizontal asymptote in the middle, or in the middle section. Totally fine. Okay? So all that we know right now is this is our only x-intercept, that's our y-intercept. The most you can graph at this point is that this has to go down towards that asymptote. It can't go up towards the asymptote because then you would get another x-intercept. And you already found the only x-intercept that exists. But we need more nice points. We have nothing in this section where x is less than -7. So what would be a nice point in that section? Well, maybe I'll plug in -8. And I would go to my factored form. I'll do it in purple here. If you plug in -8, can you see the top would be -6? And that factor would be -1. And -8 minus 1, this would be -9. And you would get -6 over +9, which is -2/3. Once you've found that point, you label it. Okay, there it is. -8, -2/3. And I have enough in that section to draw it towards the asymptotes. I have nothing in this section where x is bigger than 1. So what would be a nice point when x is bigger than 1? I'll plug in 2. And I'm going to go up, and in purple, first of all, I'm going to erase the numbers that I had. And then if I plug in 2, do you see this will be 4? 2 plus 7, this will be 9. 2 minus 1, this will be 1. We will get 4 over 9. So that's my next nice point. 4 over 9. Go to my graph. 2, 4 nines. And that's enough in this section to draw towards the asymptotes. And finally, in the middle section, I have another thing that I'm not quite sure of. I don't know if my blue graph, after it goes here, should it go down towards the asymptote or up towards the asymptote? And whenever you're unsure, just find another nice point. Maybe I'll plug in -6. What would happen if I plugged in -6? Again, I'll go up to the purple, take out my eraser, see what the new values are. If I plug in -6, this will be -4, this will be +1, and this will be -7. -4 divided by -7 is +4/7. So I can label that point -6, 4/7, and that tells me, oh, it had to go up in this section. So this example, we needed a lot of additional points to tell which asymptote it's going to go to. Sometimes one point is enough. The problem in the middle section is the one point that we had was right on the asymptote. So we could have either gone up or down to figure it out. Part of the reason it goes straight through is if you think about that x-intercept and you think about our first unit, would you agree that that x-intercept had a multiplicity of 1? And if x-intercept has a multiplicity of 1, it needs to go through that x-intercept instead of bounce. So we can use some of our knowledge from the previous unit to figure out what's going to happen. Okay, I'm going to get you to circle questions 6 and 7.